Can you hear me? Hello,
Yes.
everyone. Okay, it's
Yes.
clear and loud.
Yeah.
Okay, cool. Okay, let's get started. Just let me start sharing. I think yes. Let me start sharing. Okay, here we go. Hello, everyone. So good to see you all back again. I hope you've been enjoying your sessions since morning. So we can. What we'll do is we'll just briefly look at. Just to summarize what we did yesterday, and then we will then continue the rest of the discussions, largely focusing on standards and then architecture and things like that. So we'll just go a little deeper into the 5G architecture and understand some of the core principles. And also we have a hands-on session coming up tomorrow. So we'll just briefly discuss about that as well and just some fundamentals of what we are going to do tomorrow. Okay. Okay, so if you are able to see my screen, I think this is where we were discussing yesterday in terms of the different deployments of options for 5G. So I think I have the sketchpad still here. Yeah. So if you can see this, I think we said there are at least 8 options from what standards IMT, rather 3GPP standards define. So here specifically, option number one is largely around where 4G, the direct connection. Two is where the 5G architecture starts. So you connect 5G directly to the 5G infrastructure. So wherever there is 4G, then you use tether the 5G RAN to the 4G RAN and get the backend connectivity. So in this case, users who connect 5G to 4G tower, basically it's a broad, the interconnection between the towers is largely the baseband station connection, the BBU connection basically. So through fiber optic cable. So that's how these two towers can get interconnected. So in this case, wherever there is low deployment of 5G, subscription of 5G, in that case, you can go with small cells or a cell that is already there. Okay, I'm saying, hearing that my voice is still low. Okay, I have a new headset that I'm using yesterday. Is it better? Okay, so let me continue and see if it improves. Okay, I think Sureka says no issues. Okay, let's see. So just continue, and if it issue persists, let me know. Okay, so just to briefly finish this discussion, uh, in this case, we are looking at two scenarios, right? In a new scenario where today, as of today, we have a lot more 4G than 5G. So obviously 4G is greater than 5G. In these cases, we will make whenever a new service 5G subscription happens, in that case, there will be a 5G tower that will be provided. And if there is no backend, in this case, the 5G tower directly gets connected to the 4G and you leverage the 4G backend infrastructure to get the net internet connectivity. So this is typically how the internet access will go. So as the maturity of the 5G deployments keeps increasing, you'll see a lot more towers coming up, the backend infrastructure coming up, and finally this progression from enhanced packet core to a complete 5G core would also happen. In that case, over a period of time, there will be more 5G than 4G. But as usual, there will be 4G towers for backward compatibility or for subscribers who may not transition to 5G. So in that case, there will be the reverse of it. In that case, the 5G will tether to 4G tower will tether to 5G, and then get the backhaul of what 5G provides. Okay, so uh, now, okay, do you still have audio issues? Okay, hello, can you hear me? Ram Kamal says audio issues, not audible. Okay, and how about others? Can anybody else acknowledge or say the otherwise that it's anybody? Can you hear me? It's fine. I think somebody, yeah, Sri Krishna says it's fine. Okay, everybody says audible. Okay, fine. I think it must be some issues at some places, but that's okay. It seems to be fine. Okay, so let's continue. I think what we want to really do in this session is, so there are other interconnections. The whole deployment model is largely combinations of using 4G and 5G with a 4G backhaul, or using a 4G and a 5G with a 5G backhaul. So in this case, we have 5G connected to 4G, and 4G connects to the 4G backhaul to the internet. So in this case, we have 4G connecting to 5G and 5G connecting uh, to the 5G core. So there are other combinations where you may just have a tower and maybe directly connect to the 4G's backhaul. So because in these cases, only the tower connectivity, the radio connectivity may be there and not the backend connectivity. Similarly, there could be cases where a 4G can directly connect to 5G. So these combinations that we are discussing is largely what 3GPP has provided as a migration from 4G, 5G, 4G to 5G. So there are deployments where are pure 5G. There are deployments where there are like 5G connected to 4G. So, but at the moment, of course, in India, we don't have any of these versions yet, either an SA or an NSA option. So both standalone or non-standalone options are not there. But I'm expecting anything happens will be more on the. I heard news item where you can search that Geo directly planning to go to an SA architecture. That means they are going to change the antenna as well as provide the backhaul connectivity. So, but of course, these are all news items and not really confirmations from any vendor. So until then happens, so I think we'll have to wait. But this is what VGPP has planned from a migration point of view. I think because there was a lot of challenges when 4G really came out. Where the 4G happened, there was a lot of migration challenges in terms of how do you transition the old generation to new generation. But with 5G, it's lots more structured and lot more defined in the sense. Okay. So while we look at the options, right, I think there are two discussions that I want to have on Cloud RAN. But tomorrow, anyway, we have a session on that early morning in the first session. So I'll cover all the RAN, ORAN, vRAN, CRAN. So what is virtual RAN? What is Cloud RAN? Is virtual RAN same as Cloud RAN? What is the difference between Open RAN and Cloud RAN? So all that discussions we'll have tomorrow. So what I'll do is instead look at specifically in terms of what standards that we are looking at and what is the core architecture of 5G. So what does standards tell about 5G, and what is that we can uh, so, so basically what we can learn from the architecture diagram and envision what kind of services, what kind of roles that we can play in the various ecosystem of 5G. So that's largely what in the next few, maybe 30 minutes, we'll kind of discuss that, and then we'll take a break and then continue with the rest of the session discussion. Okay, see, I think this is one of the most important uh, principles that I think we should understand when the design of 5G was happening. Uh, if you look back, what happened in the last maybe 5 years, especially in from an IT industry point of view, there's a lot of changes that has come in the industry. So specifically after cloudification, right? When cloud started coming, so some of you who started your career maybe like 20 years ago, would know that everything was a hard fixed configuration systems. Whether you want to buy a computer or you want to deploy a network, so most of it were all fixed configuration. So one you basically has to design it very well, and once you design it, you deploy it and you maintain it for at least maybe 3 years, 4 years until the requirements change or the new hardwares come. So that is how everything was. So every computer we used to buy, workstations we used to buy, and all that. But now with AWS, Google Cloud Platform, Microsoft Azure, even Oracle, OCI, right? All that cloud platforms have made creating a network or creating a system very easy. I mean, like you just go to a cloud and just create a compute, you have a compute available. Or you can, you have, or VMware, for instance, if anybody is familiar with VMware and ESI kind of platforms where it provides virtualization. So you can buy a IBM bare metal of like very high configuration, and you can keep slicing the CPU, the memory, and the processor to create multiple VMs for you. So so this is actually started around 2010, 11 time. It started appearing in 2008, 9, but really got attention of a lot of people around 2010, 11 and became a default approach for almost all organizations to use cloud as a platform. Some companies that started way back in 90s, I see that some of them are still using hardware on-premises equipment, but slowly a lot of companies are transitioning to a cloud-enabled infrastructures, everything going to the cloud. So while all this is happening, obviously when the next generation telecom infrastructure has to be designed, so all the key principles have to be guidelines. So what exists today has to be a guideline, because you cannot still come and define a very rigid, fixed configuration telecom architecture, but that will never going to work. So what is really good or nice about the whole uh, principles? I mean, just the what they have done is different, and what went into the design of it is what we have to look into it. And I think the three core principles that we have to uh, so okay uh, so again not able to hear speaker voice. Okay, how about others? Can you hear me? Some maybe the host, anybody from BMS can you acknowledge if you can hear me? Okay, Sri Krishna says okay, thank you. Okay, uh, yes, okay, yeah, great. Yeah, I think I'm getting a lot of responses. Okay, good. Okay. So let's continue. So I think this is what has to be kept in mind, that any architecture in future, right? Whether it is the standards, people who create the standards, organizations that create standard like IETF or IEEE or ITU or any consortium, for instance, when they create standards, so they have some guiding principles. So that okay, my when we create standards, the standards should have some core pillars on which the standards will be typically based. So any system, any whether any policy or any architecture, any software that we define will have some core principles on which we base the entire architecture on. So similarly, what happened, I think, is in 5G system is three key principles that really drew the 5G architecture principles is three things: is flexibility, agility, and adaptability. So when I say flexibility, let's look at the definition. Flexibility means, okay, you can see telecom infrastructure, unlike 4G, um, people have realized that there is a lot of to cost of investment. So that means whenever you are creating a new architecture and you're trying to change so many things, especially when you're changing the radio, when you're changing the basic, the nuts and bolts of the architecture. So there's a lot of cost. And I think that's where the flexibility design comes in, because so now what the architecture does is everything is kind of split up. I'll just show you the architecture. If you look at, so this is the build, this is what we are going to discuss. See, if you look at it, there's so many building blocks now. and everything has been just ripped apart. So the whole architecture, which was completely kind of modular, but at the same time fixed configuration, has been ripped apart, and they have kind of created a lot of modules around it. So the idea of this is that any today, tomorrow, let us say when somebody wants to deploy an architecture, okay, they do not have to support everything that is required. So again, yesterday I think a lot of discussion happened on the use cases. So we heard from Vinay, Mahesh, everyone saying that when you look at 3G, 5G specifications, so there is low latency, there is high bandwidth, there is like 20 Gbps peak rate, but it is not that everybody needs everything. So that's where something is there for everyone. The architecture allows you to do something for everyone, but there will never or potentially never be a single use case where you need so much of bandwidth, so much of high density connection and low latency, because they're all trade-off as per physics. I mean, finally, it's all based on basics of physics. So there is always a trade-off when you do one with the other. When you try to have high density, your throughput will decrease. When you try to increase your peak rate, so your speed will decrease. So there'll be something that you will compromise for that. That's a trade-off, and is use case based. So if somebody wants to do cyber gaming, so let us say tomorrow there could be a virtual a gaming environment, like real hardcore gaming, then the racing, or it could be any high activity, high GPU usage gaming systems. So in those cases, the bandwidth requirement will be much higher. So compared to maybe a sensor trying to send some data. So there is always something that is different for different use cases. So if you look at this architecture, this is exactly what the architecture uh, principle is, that everything is flexible and agile. Agile means I can change. Agile means I can change to some response. So let us say today somebody starts a 5G deployment with 1,000 users, and tomorrow you want to change it to 10,000 users. 10,000 users. That means we are changing 10 times. So immediately the architecture should be able to scale up, scale down. So this is typically what a lot of e-commerce website, right? Like something like Amazon, Flipkart, they all do almost every month. So whenever there is a big billion sale, or maybe Diwali sale, or something Independence Day sale, there is suddenly spike in the number of users that would start buying. So at that time, or maybe a flash sale, a new mobile comes out and there's a flash sale of that mobile. So at that time, these platforms, right, they will have auto scaling mechanisms through Dockerizations and all that, which will automatically scale up when more users come, and automatically scale down when the users reduce. So similarly, this architecture is going to be a scale in, scale out architecture. And adaptability means change. Now, tomorrow, if there is a new requirement that comes out, or a new operator that wants to interconnect an existing system or an old generation system, so the whole interfaces should be adaptable. So if you look at it, I'll just come to this function called NEF, network exposure function. So this is one of the function that actually is used to interconnect the entire 5G to other systems, because as we go through each boxes, we'll try to understand what each function is and what the role of the function is. But the whole point is that uh, each if this has to be plugged into another, let's say 6G system or a 7G system, so all that you have to do is today, if you look at a lot of 4G to 5G transitions, so you'll have to transition the entire units of it. But in this case, tomorrow, if we have to um, plug in a 5G system to maybe a 6G or a 7G system, so we don't have to change everything, just that there is something called network exposure function. So this can be just plugged in from the outside, and that in turn can create connectivity to the entire existing system. So we'll go through those discussions, but I'm just trying to uh, map the design principles to what has been actually designed. So that's one part. So now, so this is the, again, as I said yesterday, we said that there are two organizations, right? ITU and 3GPP. So ITU only says, okay, I am going to need these kind of system agility, which is agile, which can change dynamically, which can be created, scaled in, scaled out, dynamically provisioned. A new policy control should be enabled. So new authentication system tomorrow, some new biometric authentication or something completely new SIM architecture comes. So that system should be able to adapt to the existing architecture. So those are the design principles that the specification, the requirement set. Now, next is approach. Okay, you want flexible system, you want agile system, and you want system that could change with respect to time and use cases. Then how do we do it? So this is what the 3GPP said. This is the approach that we are going to take. And in the entire architecture, you can see that all the 3GPP specifications uses ends with an F, letter F. So of course, couple of them are with M and N and all that, but otherwise most of them are F. So F means a function. So everything is a function. So the whole point that we have to understand is that in 5G, everything is a function. Okay. Second is the whole thing being service-based architecture. That means for everything is a service. So you want authentication, you want when users come into the system and they want to be authenticated. So authentication is a function. So earlier in 4G, if you have followed 4G architecture, a lot of authentication function was also combined with mobility function. So it used to work together. But now they have been separated. Tomorrow I can add a new authentication protocol or a new way to authenticate. Maybe authentication less system could also come, where maybe a digital identity system or something like that. In those cases, you can just remove the authentication function and plug in a new software, whichever supports the authentication function. So those are the kind of flexibility you'll see in these things. So everything is one function and everything is virtual. So this is where the next tomorrow we are going to do a lot of NFV lab sessions. So uh, virtualization is so critical now in today's architecture because with so many millions of scale requirements, so you do not know the because the user base is increasing every day. So more users are getting mobile. So there's already almost 2% addition of mobile users every month between Geo, Airtel subscriptions. So there is already subscriptions are happening. And look at it, like there is also mobility. I mean, yesterday we discussed that there will be something like eSIMs, so where you can program which operator you want to connect to. So in those cases, let us say, like in 1 month, there are like 1 lakh people shift from Airtel to say, Geo or Geo to Airtel, either way. So that means there is a change in the operator's requirement also. So that means for someone, the mobile operator, they have to know, okay, if I'm getting more users, then I have to increase my authentication services. I have to increase my data management services. So those are the various things that has to be changed. So that is where uh, entire thing based on virtualization. So tomorrow we'll do some sessions on Docker and Kubernetes, and you can see how Kubernetes can actually do replication very easily. So once so what happens in case of Kubernetes is that, so once we create a replication factor, you can say that when you are creating your infrastructure, you can say that I want replication factor to be 1 million. So that means at any point of time, the Kubernetes infrastructure ensures that there are exactly 1 million VMs that are running simultaneously. Even if one dies or one of the CPUs goes down, so this automatically it provisions another one. So it's quite interesting the way it does. So we will look at some of those exercises and how do we do NFV and some Dockerization and how do we pull a 5G container into a Docker, and those things are something that will get familiarized. So I will just uh, discuss two more things before I talk about control plane and data plane. See, today, if you look at API, right? So everything is an API. Um, of course, all of us have mobile phones, and I think I'm sure most of us use one or the other app. Either, of course, when we used to go to office, we used to use Ola, Uber app a lot. But now of late, we're trying to use a lot more maybe e-commerce applications. So which is more like ordering maybe food or ordering goods that you want to purchase and things like that. So if you notice, every mobile app has is a client, is a TLS client or a HTTP client, to make it simple. And for every action you do on the mobile phone, that means you book an order or you book a cab, or uh, you're browsing, say, Book My Show movie sites, or you're browsing, say, Prime Video movie listing. So it could be any action that we are doing on the mobile phone. Everything is instrumented as an API. So API, as you know, is just a function name. So in the traditional C language kind of architectures, it's like a function, A calling B. So when function A calls function so A is the caller and B is the called function. Similarly, this whole architecture, instead of being a function within the system, it is a remote procedure call. It's kind of RPC kind of a system where you invoke application with an intent, and that request goes all the way to the server, which is running in the cloud. It does the task of what you requested, comes back with the data, and the mobile displays it. So displays the result of the call. So everything is in the API, and REST is what is the industry standard now. Today, everything is a standard in industry. So just to quickly show you that. So the two things that we have to understand, irrespective of where or what service that we are learning. So today, JSON, right, and REST API and JSON API has become a standard. So REST is the way we instrument and function. So that means if I want to call, let's say, database, right? You have a database and you want to query the database to say how many. Uh, so how many users are there in the system? So it's a database query, and that is instrumented as a REST API now. So anything like you hear like MongoDB or database interfaces, data lakes. So they're all an application services, microservices. So these are all the terms that is heavily used in 5G deployment, and they all become the foundations in which each service gets deployed. So what is a REST API? REST API is very simple. It's just a way to request a particular action from the server and get the result back to the client. For instance, let's say if some of you who use banking applications, right, and or trading applications, maybe buying stocks, mutual funds through some broker website. It could be like Zerodha, Sharekhan, anything of that sort. So let us say, let's take a simple SBI bank, right, where we want to query our balance. We log in and then we want to query our balance. So what the app does is it will send an API request to api.sbi.com slash get balance. So that is how the API request will be made. So it could be as simple as doing something like this. So api.sbi.com slash get balance. Okay, so this is the call. So because it has to be secure and all that, it will do something like this: HTTPS API getbalance.com. In fact, I think in the recent past, a lot of us have used the COVID app, right, to book our vaccination slots. So and that, and incidentally, there were a lot of websites that were automating the booking of these slots, these vaccine slots, and they were all API driven. So if you see COVID API set, so this is the public APIs that the government has exposed. So everything you can see this, right? Everything is an API. So this is like generate OTP, confirm OTP, get find um, appointment by PIN district. So I can see that these are various services that the CoWIN portal provides, and everything can be accessed via an API. And all that you need is just a authentication. Put your maybe auth key is what is required, and after that you get the response. So you can imagine that every service that we talk inside this 5G architecture and every function here is accessible through a REST API. That means if one system wants to call the other system, so all that one system has to do is locate the system IP address of that API service point and call the API. So that's it. So that is all the architecture has to do. So it's become as simple as that. So excuse me. So unlike and also I'll just give you another analogy. A lot of us in networking courses, right, especially when we teach computer networking, we invariably talk about network management and network monitoring, and where SNMP based, that's one of the very classic and traditional protocols. That SNMP, there's a MIB, and the MIB has some data, and the data is being pushed to the SNMP manager, network manager, whenever the query happens. Now again, so this is the whole SNMP required a complete protocol, new protocol, and there was a requirement to write a MIB where every object has to be identified, its data type created, so everything. So now all that is gone. So all that, if you want to collect data from a network device for management and monitoring, all that is required is the manager will call a REST API, and the device will return all the data as a free flowing format. So this is basically something like so I'll just show you. For instance, I think you may have discussed this. Okay, so something called JSON. So what is JSON? JSON is just like a key value pair. So if I want to send, say, throughput information, so all that we have to just put the value here. So this doesn't require any prior knowledge of the user. Uh, uh, for the manager who's consuming this data, right? The user doesn't have to know what is the data type and everything. So everything is like a free flowing format, and all that the user has to understand. Okay, this is the throughput, so this is the value. This is the key, and this is the value. Everything is a key value pair. A key value pair. This is called key value pair. So everything is now formatted as a key value pair. The same thing you will see again in the 5G services. When we look at some of the 5G services, I'll show you some specs and some examples as well. So all that we can see that it's all based on API and free flowing formats. So, so this is what is the principle, and finally programmability and automation. So this is something very critical in today's high dense in deployments and infrastructure deployment, right? Because today we are not in a country like India, the number of subscriptions, or it's close to millions. It's close to already 50 to 60 million connections in a small within within maybe a set of regions. So in those cases, and if you want to manage, deploy antennas, like thousands of antennas are going to be there. Today, you know that there's already connected transformers. Like today, we have one transformer on the street, and almost every street. We used to see them a lot earlier, especially in Bangalore. We used to see a lot of transformers, but of late they've become much smaller in size and much lesser everywhere. So it means there are some new things happening there. So those, and any transformer obviously has its own characteristics. There's of course its throughput, its load on it, maybe some mechanical parts, oil in the transformer. I don't know what some things could be there. So they're all getting connected so that you can get a dashboard of all transformers in the city of, say, Delhi, Mumbai, Bangalore, anywhere, and then be able to view the transformers. Where it was something goes down, you can potentially diagnose it remotely as well. So everything is connected. Similarly, every antenna, connected antenna is another thing, where every tower will be connected, and you can pretty much understand what is happening on the tower. So suppose some tower is running on a generator, and the generator has some fuel in it. So you can actually get the statistics on top, which generator has what fuel markings, what is the backup available. So a lot of things. So I mean, this is where, and because it's all connected, you can now send commands to it, get metric from it. So a lot of programmability. That's where Python becomes a very core skill for 5G implementation, automation, because that's one of the libraries. You'll see a lot of 5G Python libraries coming out now. So automation, so Python, REST API, JSON, Docker, Kubernetes, and Datadog. These are the kind of basic building blocks that you'll see in real deployments of 5G. Okay, so without much other delay, let's now try to understand. Okay, now that all these good things are there, so there's one part about SDN, control plane data plane separation. So I will cover as part of the architecture discussion. So let's see. Okay, what is the core function? Okay, so 5G has so many building blocks. Of course, it's quite a complex system. But what are its core? capabilities. If we just categorize it, right, there are like 13 to 15 boxes. Actually, there are 13. Sometimes you can get one addition box. So we'll talk about that. But if you categorize it, right, from a network point of view, so let us say I'll present it back. So if we categorize the services of 5G, so this is where I think you can remember all the building blocks of 5G if you can go by the logic of what we do every day. So today we start with we power on the mobile phone. The mobile phone once the mobile is powered on, and if it has battery capability, then it will start hunting for a tower. So it will start looking out, okay, where is my nearest tower? And based on the signal strength, the tower having the highest signal strength, it will make a layer one connection. So it's like it's not physical over the air, but we can still call it as in the OSI stack. I can still say that that is a layer one connectivity. So instead of connecting through a cable, it's over the wire. That's the only difference. So once the mobile phone is locates the tower, and then the tower will challenge the mobile phone to say, okay, are you part of my operations or my operator? So then the mobile function, we will see some identifiers in 5G. There is already IMEI number, which is international equipment number, which is there in the mobile phone. There's also something called SUCI, subscriber unique concealed identifier. There's quite a few things that 5G has introduced. So we'll discuss some of that as part of the security as well, because that's where a lot of interesting things that happen as part of the 5G security. So the first thing that happens is that the mobile comes out, uh, gets connected to the tower, and then registers yourself. So once the registration is successful, assuming that you uh, have a valid plan, you have paid money, you're not being blocked by any government or law police authorities from using the mobile, or then if all that is clean and good, so you'll be able to connect to your tower, and the signal comes alive, and you're now your data, voice, everything is available for people to use, connect. So all that part you can call it as session registration and connection management. So which basically comes to this particular three blocks that we see, right? These are the three parts which is primarily used for user registration, user management, and then tracking the lifetime of the user, whether till the user is powered off, the phone gets powered off. So that is all about connection. Next is admission. So obviously, just because you have a plan, right, and you have paid the money, so the admission is not guaranteed, because it depends on if that there could be some numbers, that mobile numbers that you want to blacklist at the tower. Some numbers you want to put it to monitoring. So there could be a lot of such activity that can happen, and all that come under network admission control. So admission control means you're coming into the network, but the network tries to uh, restrict you or try to actually contain you to some things that you are only entitled. So let us say if you buy a SIM and only subscribe for voice call and not SMS and data plan, then somebody has to tell the infrastructure that, okay, this subscriber has only subscribed for voice call, and when the subscriber tries to send an SMS, do not accept it or block it. So that is where the policy control function and the user data user there's one more UPF, user plane function. So these are the two, they all work together to ensure that you cannot get service for which you are not subscribed, for which you are not basically paid the cost. So so this is admission control. So it's very simple to understand that admission is all security, firewall, policy. So all that comes under network admission. So then session management is interesting again, because session management means once you are in the network, somebody has to keep tracking you, because you are connected all the time to the network. So either the battery dies, or maybe you go out of the coverage area, or maybe you go somewhere in a bunker that you are not able to access the tower. So until then, every second of the connection, there has to be somebody to keep track you, because when you are roaming, so they have to know that, okay, you are roaming from A one tower to another tower. So it all management of which tower you're living, which tower you're entering. So all that session management, and very core part of uh, the functions of providing IP address, renewing IP address, all that is part of session management. So we'll see how those things happen. Then user plane and user management, as I said, this is largely around managing the user policies, ensuring that the user is gets the service for which the user has paid the cost to it. So for instance, let us say tomorrow, if you are a sensor and your subscription plan is that you're only sending say 100 bytes of data every minute. So then because let us say if tomorrow the sensors become somehow malicious, right? Somebody hacks the sensor and they start sending large amount of data. So that kind of use case specific limitations, restrictions has to be done. So a sensor cannot suddenly, let us say tomorrow we talk about connected fridge. So and somehow the fridge wakes up and tries to do something else than other than it tries to do. So because as a fridge, we know, as a manufacturer knows, okay, what is the kind of data the fridge is going to send, and suddenly it cannot send more than say 1 megabytes of data. I mean, it's very unusual for a fridge to be sending say 1 gigabyte, 1 megabyte of data. It could be few thousands or 100 bytes of data. So if that kind of activity happened because of a malicious intent, or because the fridge or maybe the device itself getting hacked, then there should be some control checks and balances in place, and that is where the user plane function and user data plane function, they all do together. So we will talk about it along with user plane and data plane separation. See, all these 5 bullets, right? The registration, network admission, session management, user plane functions, they're all there in telecellular technologies. Until 4G, you could see these functions. So something that is brand new, that is only the very first time happening in a telecom world, is the network slicing. And this is where, so we have a session on, I think Thursday, where Nokia is going to show us what network slicing works, and going to have some demo on network slicing. So, but it's very interesting on how slicing means, and so we'll discuss this maybe in 10-15 minutes. Okay, so I'm not watching the chat. Uh, okay, so any question, folks? So let me know. Just give a minute for you to ask any questions. So here I'm trying to highlight that everything is a function. So this is very important. Tomorrow, when you either as a researcher or maybe as a developer or a network operator, you try to work on 5G, you will have to be aware that every element of 5G is a softwareized. So in fact, we have one session on Friday. We're actually specifically talking about softwareization of 5G and what does it mean to say that it's a software, and why that shift to software is there. And that doesn't mean that there's no hardware at all. I mean, obviously there has to be hardware, but the hardware in that case is called as COTS hardware. So the COTS, commercial off the shelf. So commercial off the shelf. So that means if I want to create a let us say a broad BBU, right, a baseband unit. Um, so in that case, today if you look at it, if you want a baseband unit, then you have to go to one of the vendor like Nokia, maybe Ericsson, and then buy the hardware, and there you run their hardware and you run their software, everything provided by that vendor. But tomorrow it's not necessary that it has to be that way. So what Geo can do is, if they want to create a tower and create a baseband unit, so all that they do is they can bring their own Intel 8 core or maybe AIML based chip based hardware, and say, ask Nokia, okay, just give me a software, a BBU software, I'll run it on my own hardware. So that is where commercial off the shelf, this kind of architecture is where the softwareization part of 5G is going to happen. And one is, how do you, now the question is, okay, today, if when you want to run a software, right, I mean, all of us have experienced in our, when we do the lab sessions, and when we write code. So obviously, when we write code, hello.c, hello world.c, we do a compilation, CC, if you are using C language, then you do GCC. If you are using Java, you'll run a Java program, or if you're using Python, you'll run with the Python. So there's something you're running on your system and giving it, because if it's your own hardware, when you ship the software, you can know that it's your own hardware, so you'll run it. So sometimes, just to give an example, let us say um, if I mean, this is something, right? Today we buy mobile phones, so we are buying mobile phone, maybe either Nokia, Siemens, or maybe Motorola, or Micromax. We could be buying any of these mobile phones. So the mobile phone comes with its own Android OS. I mean, of course, if it's Apple, it will be iOS. If it's Android, it will be Android phone. Now, can tomorrow, let's say today it's there already, but it's not available for everyone to do it. There's something called side loading, where you can remove the existing operating system and put your own operating system on a mobile phone. So that already methods and approaches are available. But it's not that you can just do a double click and get a new software. But just imagine if tomorrow there's a new mobile company, right, which provides a very good operating system, very secure, very easy to use, maybe more efficient operating system. And you just like your iPhone, right? You like the iPhone because it's nice, good, and very aesthetic phone. So now the question is, can you just mix and match your mobile phone mobile operating system? So that is going to happen. That is when you can bring your own phone. So like bring your own phone and just use whatever software you want to use. So this was not happening until last 10 years, like where everything was hardware fixed configuration. But now with SDN, a lot of vendors are ready to just ship the software and not necessarily hardware. So for instance, Cisco or even companies like Ericsson, Nokia, they can just provide their core routing algorithm as a software. Or there somebody is very good in firewall capability, they can just use a firewall as a code. So you just take their code and you run it on your machine that you are already having. So that is what we'll see tomorrow, how to take somebody's code and run it on your machine, and your machine can be very different from which the code was written. So the code could have been, today we know that portability, of course, Java kind of makes it easy because of abstractions. But the point is that how do you take some code, let us say if I develop a machine learning algorithm in my company, and and you ask me saying that I have my own hardware, let me run it, just give me the software. So when I give you the software, there's so many dependencies that I'll have to package and give it to you. And in a way that it will run just seamlessly on your virtual machine. So how do you do that? That's where the Dockerization concept of Docker is so important. It's so cool as well. So that you can just Dockerize it, put everything in a Docker, and I just give you a Docker instead of giving my software. And you will not even know what is there in my software. All that you will have to do is run the Docker, download it to your system and say Docker run, and give the software name, and it starts running. So that is where the ease of um, provisioning of software, separation of hardware and softwareization of these components that we are talking about is going to happen. And that's very important to understand the softwareization aspect of this 5G. So in the 4G world, so all these systems like that authentication function, session management function, they were all specific hardware that every company sold to the customers, to their network operators. Now, what will happen in the future is that, let me already show you an example of that. So which is, let me escape this. Okay. So I'll just show you this. This is very interesting company. So Oracle 5G, right? We all know Oracle as a database company. Right? I mean, Oracle means, okay, earlier it used to be the databases. So, but what is interesting is if you look at Oracle uh, functions, right? See, today, if you look at this particular data sheet, so this is called policy control function. So which is basically here, PCF. Okay, what you see here is PCF. So Oracle is saying that, okay, just buy my PCF solution and you can put it integrate in your telecom operator. So if I'm a telecom operator, let's say if I'm Geo and I'm looking to build a new 5G architecture, then earlier they had to really struggle because everybody used to provide a particular service and they had to give their hardware. And basically, you have to run their hardware and you have to use that in your platform. Now, and we know that, right? And not every company is good at everything. So for instance, some companies are very good in AI ML, some companies are very good in security, and some companies are very good in routing. For instance, Cisco is the leader in routing technology, BGP. So a lot of strengths are there, and because if you want to, if you buy say one vendor's equipment, they may not have the best in class for all the features that you want. So now but you can, but just because of that, you cannot buy hundreds of hardware and put everything in the infrastructure. So now with this kind of softwareization, so I can go cherry pick either one um, function from say what Oracle provides. Maybe I can pick one from what Microsoft provides, maybe another one what Cisco provides, another one from maybe Ericsson provides, and then I can put all of them together and then have another system that could monitor all of them. So that's where the whole point about agility, flexibility, adaptability, all these points come back to the point, to the whole concept that all of them are just software versions of the functions, and you can run it on your hardware. You can maybe take a laptop and run the slicing function. Maybe you take a VM and run the registration function. So it could be anything. So that's how this whole thing is going to work. Okay. So now, so we'll just try to understand the two core concepts here. See, one is called the data plane and the control plane. And why is this shown separately? If you look at if I just present this, right, you can see that there are some box that are underneath and some box which are like kind of connected over the top. So that means there is a very clean separation of user plane and control plane. So that is what this is called, UP and CP. In also, you can also call it as DP and CP. So UP, user plane, and data plane is analogous. They kind of mean the same. CP is always control plane, which basically controls some activities, some actions, and some instructions, you can say, for the data plane to do things. Okay, so I'll just pause here for a few minutes, for a minute, and ask any questions, guys. So are you have any top of your mind questions, and let me know. I'll just give another minute for people if there's any questions specifically around these concepts of virtualization, hardware, agnostic, COTS kind of behavior. Okay. See anyone asking any questions, maybe another 10 seconds, and then we'll go into the next topic. So we're just like 3:40, right? So I think we just maybe let's take a maybe like 5-6 minute break. So okay. Means buying software from vendors and run our own way. Yes, exactly, Sureka. I think so. In fact, you can view your question in a different way. Can I, in other words, can I buy any hardware and run any software? The answer is yes. So you can see, because look at it, right? Today, the cost, right? When you buy a mobile phone, the phone cost, hardware cost is just maybe 2,000, 3,000 rupees, because it's all semiconductors and they are manufactured in bulk. Billions and billions of components are manufactured. It's always available in bulk and they're cheaper to assemble. But the cost that we give for anything is the largely around the software, because hardware is, of course, there is a lot of things that hardware happens because a lot of research would have happened, the silicon, the VLSI kind of technologies that have been used to build. So at some point of time, it becomes a production. It becomes something like a commodity, so that you can just buy. Like today, a toothpaste is a commodity. You can just go to a shop and buy a toothpaste. So similarly, hardware is becoming commoditized and commercialized. That means there are manufacturers, and from where those manufacturers are, they can deliver things at a very low cost, as a fraction of the cost that it takes to build on your own. So that is something that what we as a country, India, has to do a lot, create our own hardware. And that's where I hopefully a lot of private players are already saying that they want to start silicon manufacturing, semiconductor chipset manufacturing, AI ML chips inside the CPUs. So all that is going to really change. And hopefully in the next 5 to 10 years, we'll see a lot of Indian semiconductor companies. But yes, so the whole point is you can buy your own hardware. It's like you want to build a home, so you have a plan. Your architect has given you a plan, and now you want to choose a material, and you can buy. You don't have to buy the whole building material from one company, right? You basically maybe buy a Birla cement, or maybe I'm just giving some examples, or you may buy a something like a Nitco tiles. I mean, I don't know. There's some tiles, or maybe uh, uh, what is that, anchor switch. So it could be different. So you're basically, if when you, the home is a classic example, which basically the 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 separation, the service based architecture. I think our homes are the best example, because everything is different. So somebody else, see, if you want gas cooking gas into our home, it is from a different it is a different vendor. So there are different, water supply comes from a different vendor. So but we are able to put all of them together and then manage, run, and live in the homes. So similarly, in 5G, what you're going to see is that, or rather, it's going to be more easy to do. It's not that 4G did not do it. The 4G, it was a lot more hardware based, so there was more vendor, what they call as there's a term that they use, um, vendor mm, specific or something around that. So where you are kind of married to the vendor, because you have to use the vendor, and it's not easy to replace this equipment. But now, because you can bring your own hardware, or you can buy the hardware separately and buy the software separately. Maybe if you don't like the software, you can 2 years you can change the software. You can just upgrade, remove the old version and put the new version. So that is where that is what the flexibility that this architecture uh, provides. Okay, so Nagaraj is asking what is meant by stateful and stateless in UDM. So just give me a minute. I'll come to that and explain you stateful and stateless. But just to let you quickly answer your question, stateful is when you track something from the time of creation to the time of deletion. So that means you, as a session, let us say we, for instance, when we come into a system, into a mobile, let's say when our mobile phone gets authenticated, it is stateful, because the authentication state has to be maintained through the lifetime of our session. So that means that means if I bring my phone with some IMEI number, and I authenticate the phone, and then I replace my SIM with. So let us say, just imagine, Nagaraj, like if there is a way to just use a Geo SIM, or maybe for which you are paid money, and then connect your phone to it, and then somehow magically replace that SIM with another SIM uh, on which you're not paid the money. So that cannot happen, because your session is stateful. That means the session and the authentication key, the security keys that has been created for you, they remain till the lifetime of the session. So until you power off, or maybe the call drops, or maybe the signal drops, something has to happen. Until then, it is maintained. Stateless is something that where you don't have to maintain the state of the session. So suppose you come, for instance, something like to give an example of stateful and stateless, right? For instance, I think so it's like this, right? Let's say you go to a restaurant, and in restaurant you're ordering food. So that means the restaurant is, you keep ordering food and keep getting the food delivered to your table. So the entire thing is stateful, because at the end of it, so you have to pay the money for pay the price for which you prepare price for the food that you ordered. So that means the cashier in the hotel is keeping track of your session. So that is called stateful. So on the other hand, let's say you do a pickup, right? It's like you just go and pick up something from maybe like Swiggy, Ola kind of Zomato kind of thing, where you already given some prepaid. So all that the delivery person has to go there, pick it up, and come out. So the cashier doesn't have to maintain your state to the system. There's already because you're very transitionary in that state. So in the sense that you don't have to maintain the previous actions to do the next action. For instance, in case of food ordering, so there is always a state maintained. That means you're ordering more food, so the more billing is happening. So that means you are keeping track of your previous action when you're doing the next action. In case of stateless, you don't have to know your previous action at all when you give a new action. So suppose something like, let us say um, as I said, I mean, something that I can easily think of is just you go pick up something and come back. So that means you can go do it any number of times. So let us say you can order a food, go pick it up, come home. Again, you can go again order something, pick it up, and come home. That means nobody bothers about your previous state. But let us say on the other hand, if you are not completing the transaction, then the next transaction, then they will ask you, okay, you are not paid because I know that you came yesterday, you not paid the money, so I will not give the maybe another delivery again. So that is called stateful. The same. So we will come to the UDP where stateful is useful, where stateful is useful. Stateful is very expensive because the system has to keep track of you all the time, right? All the time it has to keep track of you. So that is why it is expensive, but it is necessary sometimes for some security purposes. Firewalling has to be stateful. Whereas there is something like I'm delivering a video to you. In those cases, I may not be stateful. I can just throw up whenever I get a video, I will just deliver it to your phone, and the phone is like SMS, for instance. SMS comes and it is delivered. It's stateless. So and the server doesn't have to know anything about it. So on the previous SMS or something like that. So there are certain stateless and there's stateful. That is what is called stateless and stateful um, analogy. But we can go into the detail. Okay, so maybe 3:50. So you want to take everyone a 5-minute break, maybe till 3:55, and then we will. Sorry, 3:55, and then we'll continue after that. Meanwhile, anyone has questions, you can just keep throwing it on the chat. Okay, so let's get started. Okay, now let's continue and we'll look at, so there's a couple of references I was just trying to share on the chat window. Maybe if you're just, you can copy or copy paste it or bookmark it. So they're pretty good references. And open end interface is something that I think as we should all pay more attention to open air interface, because that is standardizing a lot of open sourcing a lot of 5G infrastructure components. So I think that's going to be very critical to use to follow open air. So open air interface, it's a group of companies that are coming together and trying to create a lot of open source of 5G. So if you want to really look at open source 5G, this is a place where you can do it. But just be aware that everything is not working, doesn't work easily. So it will take quite a bit of effort to get it to work in your environment, but it's a good start. So if you dedicate like 1 or 2 weeks of your time, then very easily you can create your own RAN and your own 5G core within your lab. So just um, keep your tab on this specifically open air interface. There is a registration. You can go register, become a member as well, and you'll keep getting updates and all that. But quite a few events. Of course, they also do very intense workshops. Of course, quite expensive at the same time. But now it's all online, so it should be able to easy to attend as well if you want to attend. I think more than anything, I think I like the projects that they are creating. So for instance, if you go into RAN, uh, so in fact, the way they do it is that you can actually bring a real phone and then connect, because the whole open air interface works. It's not a software, it's not a simulator. So this is not a simulator, it is actually a real 5G network, RAN and core. So it's a real network 5G. So that means if you want to connect a 5G, if you want to create this project, all that you need is a 5G phone, and then a 5G antenna that you can buy from outside, from any electronics vendor, and then you can run their RAN software, which is open RAN software, and then bring it up. So it's not a simulator. This is not like NS2, NS3 simulator. This is actually a real software that will help you to build block by block of 5G in your lab, in your home, or in your college campus, or whatever you want to do it, you can actually do it. So there are quite a few videos on which, so this is the project code. So this is where they release their project code. This is like a GitHub. So you can download. So these are the various file layers. So, but this is not a simulator. So this requires real 5G antenna, real 5G phone but you get the software so that you can run it on your hardware and then have an antenna, or maybe you can take a USB based antenna, 5G module. So connect it to your laptop like an antenna, then have a 5G phone, and then run the software here. Okay, so this is something just wanted to share. And this presentation is pretty good. This is something that was presented by the open air interface about the status of the open air projects. So what is the, where is it happening? What is the status and all that? So this has very good information on, of course, the high level architecture. So of course the use cases, this I think you are familiar now. Everybody talks about this is the ITU diagram, and this is the, so obviously the slicing that we'll see tomorrow, where each network is sliced to different use cases. Then what we discussed today about, okay, they call it as flexible, scalable, and customizable. We are calling that flexible, adaptable, and agile. So it all similar, uh, I think similar vocabulary. And this is the same picture that I also am using in my slide. So from ITU 3GPP specification. And so this is, they are comparing what is it different from 4G to 5G. So I've skipped 4G part completely because I don't want to really get stuck on 4G. This is required only for people who have 4G already and they want to transition to 5G. And that is where this thing makes sense. So here we are talking about the core function. This is where I think we also stopped. So basically the categorization of all the various functions and what it does. So we'll now discuss all this. And this is where I was telling about the HTTP REST API, right? So every 5G function is implemented as a REST interface. So that is where, what is a REST protocol? A REST protocol would look something like this. For L2, of course, is the MAC layer, IP layer, TCP, TLS, HTTPS, which is the HTTP 2.0 specification, and in top of that, applications. So there is something called API kit that 5G has developed. So the 3GPP has actually specified the API names also. So that means if anybody designs their own authentication function, service function, so they will have a standard API name that they should expose the functionality. So that is what this whole thing is about. So I'll show you that also. I think I am here somewhere. This one, yeah, this specification. This is called 5G 3GPP's 5G service-based architecture specification. So this is where you can see all these API names, right, which are mandatory. And these are various data that you can send as part of the function. So whenever you become an implementer, let us say you get a chance to actually implement any of the network function, authentication function, authorization function. So all that you'll have to do is create a web server through, you can run something like Nginx or Tomcat kind of web server, and then create a webhook or a microservice. It could be in Golang or Java, and then create these API interfaces for which you can write the code to actually meet those API calls. So this is pretty much what the specification. So the actual understanding of 5G, of course, the details of it, right? You'll get it only if you go through these kind of documents. And there's something like uh, 20 to 25 such documents, each of say 50 to 100 pages. So it's not something, yeah, it is going to take time. And I think the way to tackle 5G is, okay, have a high level knowledge architecture, something like, for instance, what typically a medical students do, right? They know the general anatomy of the human body, and then there are different specializations that they actually build as they learn the details of the medical study, right? Science. So similarly, I think I would suggest, based on your area of work or your research interest, So look at it, have a functional view, a high level architecture view, and then you can go into somebody interested more in security. So they can go into things like authentication, policy, functions. Somebody more interested in routing protocols, QoS, queuing theory, something like resource reservations, or those things can look at more at the AMF level, AMF, SUF layer. So there are different and the user plane function layers. So there are different things for different people based on the interest. But uh, as if you ask me as a practitioner, I'm more focused on the cybersecurity aspect of 5G. So obviously, when everything becomes a software, and these softwares are accessible through hardware. So because the way the whole architecture will be implemented is that, so on the antenna, right? And the antenna we have a RAN where the antenna, radio, everything exists, and below the antenna is where the BBU happens, the broadband, the base unit. Uh, okay, so that base unit is a hardware, and that hardware will call out to these functions which could be running in any cloud. So for instance, if there is a tower sitting, a tower, under the tower there is a hardware, and that hardware will be running a software which will call out from the tower. As you can see here, so everywhere there is a line running. So between UE is user equipment, to AMF there is a line. From RAN to AMF there is a line. That means these are the interfaces that can be called. So even if the whole control plane, the top of this is running inside a cloud, they can still be invoked by the hardware through incidentally the internet. So that means this could be completely located somewhere, not even maybe in the same country. It could be running in some other country as well. So that is how the flexibility of this architecture is. Okay, so I think let's now jump into to understand the specific uh, of, uh, of this architecture, right? So yeah, so there are two pictures. This is exactly from the specification, because specifications are very, so it's like the physics textbook. It's not too fancy, and it's mostly two-dimensional kind of illustration, because they only try to explain a concept and not try to relate it with a use case. So because of that, I got one more slide. This is from I think net maniacs or something like that. So they have a very nice. Uh, Actually, you can see from how the user equipment, how it connects to the antenna, from the antenna to the data plane. This is where the cloud. This is where the standard Google's and Amazon, Ola's kind of guys will be running on top of the cloud here. But we are the phone. We are pretty much the consumer at this point of time, and this could be a different. If it's a private 5G, then it could be just a Tata Motors running their own 5G network. Could be just the Tata cars talking to them, or a Honda having their own 5G network. Then this the user equipment will be largely a small SIM, a car with a small SIM or something like that. Okay, so so what we'll try to do in the next 30 minutes is just go into these things and look at the 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 philosophy of these components and why these are placed in the way they are today. I mean, it actually it's very interesting. It's like just like the human body, right? It's anatomy and the different organs. So similarly, the 5G component, it's easy to understand if you know the function of each unit. So it becomes very logical for you to even think of it. I mean, today, I'm sure all of you know these things. There's nothing new that 5G is going to tell you in terms of in terms of authentication is something that we are all already familiar. Authorization, we are familiar. Access control is whitelisting, blacklisting someone is also something that's very familiar on a network level. Then routing is, we all know. QoS, I'm sure a lot of you have researched on QoS. So everything is not new in that sense, but only thing that 3GPP has structured is that there is a specific boundary and a purpose for each of them, and that's where those functions should reside. So while you're looking at this picture, right, where you have NEF, NRF, UDF, AUSF, for instance, I'll start with the bottom line right here. UE is the user equipment. So I'll just explain the terms and then we'll see the functions, and I'll draw some, I use the whiteboard to draw a few scenarios and we can go through it next. So UE basically means user equipment. So it's basically anything. Today it's mobile, tomorrow it could be our refrigerator, or it could be somebody's car, or it could be a bus or something like this. Could be anything is user equipment. G node B is the next generation node B. So which is basically the base station, as BTS, as the old 3G um, students used to call BTS. Now it is called GNB, next generation node B. Basically an antenna. It's like a tower with all of radio, antenna, plus a BBU, a broadband unit, which is doing basically signal processing and trying to encrypt the data, decrypt the data, uh, converting signals, and then digitizing it. So that's the whole job of the node. Then comes the user plane. So this is the, if you look at it, right, if you look at the blue line, right, the blue line, so there's a reason why that is in thick and a straight line. So that basically means that whatever whatever uh, user data is being sent, so that data is going from the user mobile phone into the cloud and directly into another equipment and finally to the internet. So this is how it looks like. Okay, so though logically you can say that any data plane, that means if there is nobody to control you, in the sense there's nobody to, if it's open infrastructure, let us say a road, for instance, a road, we just come into a road, maybe something like our national highway, Mysore Bangalore road, or something like that, any road that we can think of. So you just enter the road and keep driving and you exit the road. So this is the road basically. So this road is nothing but your highway on which all the data packets, all the SMS, the video, audio that we all enjoy, they all go in this path. Now, the only problem is, so just give me a minute. Just a second. I'm getting a phone call. I have to take that. Just sorry. Just give me a minute. I'll just talk.
Sandeep sir?
Yeah, hello. Yeah, sorry. Yeah, so actually, my UPS is not working at home. So there was a guy who had come, wanted to get directions to come to my home. So I just had to take his call.
Okay.
Yeah, because without UPS it's very difficult of late, just banking on the
Yes, sir.
KB power. So, yeah. Okay, so sorry for that disruption, guys. So let me start again. Okay, here we go. Can you see what I'm sharing? I think it should be visible. Okay, so let's quickly go through these functions, and then I will just show you some of the commercially available Docker versions of these functions. So that way you can pull the Docker and then try to bring it up in your laptop and all that. Though it may not work, but at least you can get the feel of getting these modules into your system. So okay, so if you see this, right, this is like a road. The one in blue is actually what you see is like a highway path, just like a road. So typically, if there was nobody to stop you on the road, so if there was nobody to stop you on the road, so all that you had to do is come onto the road, keep driving, and then go from one place to another place, right? This is typically what happens. But let's say there's something that is required for you to drive on the road. One, you have to have a valid license. Of course, you should have a vehicle, and then you should have a valid license. Then you should have a registration to the vehicle. You should have some insurance to the vehicle. Then, if there is a toll, you have to pay the toll. And if you have a toll, they will tell you, okay, you can only the toll is different for different segments of the road. So this is exactly what you see in this architecture. So somebody's data is going from your data for the mobile phone is going from here to your cloud. Let's say you are watching a Netflix movie. So all that from your mobile phone, you are basically accessing your mobile and sending your data and accessing the Netflix movie on your phone. So, but before the movie is actually delivered to you through the internet, through the mobile network, so there is a lot of checks and balances that the mobile network does. And this is what is called as control plane. The control plane is nothing but a function which basically tries to uh, control your movement in the network. So basically, they will ensure that you don't overuse a resource, or you do not try to get others' data. Then you don't try to you get what you only subscribe to. So that means, let's say you pay a toll from point A to point B. So when you exit the point B, that's it. You have to pay another toll to come back. So you cannot use the same ticket. So similar way, all these functions at the top, they're all trying to control or enforce some order for the traffic that is going on in the road. So it's like everybody has a role. For instance, PCF. It's like the policy control function that defines your entitlements, your policy. So this is more like the government, right? There. So for instance, in case of a traffic system, somebody makes the rules. Okay, you have to put an indicator to turn left, put a right indicator, left indicator. Then you have to stop. So when a stop sign comes, when a red light comes, you have to stop. So there's a lot of policy statements that are made, and all that is actually is called PCF, policy control function. So what the policy control function is basically tells you what is the policy that you have, what is the entitlement. So this is when we buy a network plan. Let's say we buy a mobile plan so for instance, somebody has a 2 Gbps per day and with 100 Mbps bandwidth. So all that is basically provisioned into this policy control plane. So all your bandwidth management, subscription management, everything is gets programmed here. So when you buy a plan, the first thing the plan, when you subscribe to a plan, all the plan details gets programmed here. So when your traffic comes, so as you know that, so what basically happens is that when your traffic comes, so the traffic is now is now controlled by UPF, which is the user plane function. That in turn will ask the session management function asking for policy, and the entire policy will come here, will be fetched, and it will be enforced here. So this is called a data plane control plane separation, because the decision of allowing you into the network, or allowing you at a certain speed, or allowing you access to service, is all controlled by the whole set of components that are running on the top. So that is why this is called control plane, and what you see in the blue is called the data plane. So this is like a road on which you travel, and rest of the people on the top you see is all enforcers, regulators, maybe tax collectors. All those guys who are there, they're all in the top trying to ensure that you pay for what you buy, and you pay for every service, and when you get the service that you're paid for and nothing else. So that is the whole thing. So if you want to if I want to just expand the acronyms, right? So GNB is, of course, the BTS or the base station. UPF is user plane function. DN is the data network. This is actual cloud that we access from our phones, right? It would be Google Maps, Google Mail, it could be Zomato app, or it could be anything. So those are the data network from which the data would come. So now the function is NSSF is network. This is the slicing function, network selection, slicing selection function. Then this is called AUSF, authentication function. EMF is access and mobility function. This is what manages your connectivity. So if you look at this, this is the only function to which the user directly connects. So the user connects our user, when you say user, our phones, they connect directly to AMF, only AMF, and not anything else in the architecture. So if the question is what is the function to which the user directly connects in the 5G architecture, it's AMF, which is authentication, access and mobility function. AMF is access and mobility function, because this is where all the cell tower termination, right? The signal termination, our SIM authentication. So everything happens in AMF. This is a key part in which all the authentication functions happen. The SIM. So this is also where the mobility is also handled. That means when you are going from one, one place to another place. So let us say if you are going from so if you are going, say, yeah, I'll just have this here. So let us say if you are going from one tower, this is one tower, okay, and there's another tower here, and what happens is these two towers have something called BBU, the baseband unit, and they would be connected to an AMF, which is that access mobility function. So this is let us take an example of say BSNL, right? And they are running the AMF here, access and mobility function, AMF, right? They're running AMF function. So when user is here, let us say this is the user, and user is walking from one tower to another, or walking, running, or driving from one place to another place. The user comes here. This is the user, and the user is coming here, right? So this is the same user who's walking and coming. So when the user comes, so what happens is that uh, so user is initially connected to this tower. So that means the AMF, as we can see from the picture, right? So this line is what is the direct connectivity from AMF. So, uh, so, yes. So logically, of course, you cannot see our phone directly doesn't connect it. So this is the logical connection, but physically, actually, they are connect through the tower only. So everything is finally to the tower. They come like this and go to AMF. But just from a logical connection point of view, so we show that the user is directly connecting to AMF. That means all the user management functions typically happen at that at the AMF. So when in case of uh, roaming, so what happens is when the user is roaming from one place to another place, um, uh, so so when the user mobile phone will keep tracking the strength of the signal, and that strength of the signal keeps decreasing when the user keeps roaming. So if this is tower A and tower B, so when the user roams from tower A to tower B, the user's cell phone detects that it's losing signal from tower A and gaining signal from tower B. So this is, and then it will now tell tower B that, okay, I want to connect to you, and tower B will now connect to AMF and ask, okay, I have a user who is trying to connect to me. Do you know anything about the user? The AMF will say, okay, that user was actually coming from tower A, and the tower A will hand off all the security metrics, everything to tower B, and the user will now break the connection on A and make the connection on B. So this is called make and break mode. So where you make a connection on the new tower and break the connection on the old tower. So all mobility function, access management function is what is basically handled by AMF. So this is what is called AMF. So now then comes something now. So you are connected. Let us say you power on your mobile phone. The signal comes alive, and the signal and the mobile starts hunting for a tower. So once it gets a tower, it will try to physically in the layer one connectivity happens. Now the question is, will tower allow you to connect? Now yes, tower will allow you to connect provided you pass the authentication credentials and check of the tower. So, so there is some kind of identity, as you can see, some ID card that we will show. So we will talk about what are the identities of 5G in the security session. So just for now, imagine that you have a unique number that is given to you when you buy the SIM. So when you buy the SIM from an operator, the SIM at that time provisions your unique identifier into your SIM and then gives you the SIM. So that means it recognizes that the SIM is part of that mobile provider. So once you insert the SIM and switch on your mobile phone, so the mobile phone detects a signal, connects to the tower, and then the tower in turn will connect it to AMF, and the tower will now challenge for credentials with the SIM. Once the SIM passes the credentials, a connection is established, and that whole authentication that happens, right, is all part of this module called AMF. So, sorry, AUSF, Authentication Service Function. Okay. So these are the two things that we discuss. So then comes the session management function. So now what happened? Let's say you are connected to the tower. You are connected to access layer. That means you have been admitted into the cell tower. You have been admitted into the cellular network by the authentication because you have passed the authentication. Now, what is the very fundamental thing that you need to communicate, right? So now you have got everything with you, but you need one thing that you have to use to communicate. And what is that? IP address. So without an IP, you cannot actually start any of your data connection, right? So somebody has to assign an IP address to you, ensure that you do DHCP kind of thing. If so you would have studied DHCP, dynamic host control protocol, host configuration protocol. So which basically does the IP address assignments. So all the IP address assignment. So IP address assignment, keeping track of your lifetime, where are you located? So if you just step back a bit and see what all information the tower is finding, right? It is finding your location. That means because it's connected to this tower. Uh, you know that it is connected to this tower, and because of that tower, you know that it is coming from a specific geography. So you know in which area, maybe this is say some place in Delhi or some particular place in Bangalore. It could be say something like MG Road, Bangalore. So that way we know the location of the tower. See, this is these functions, right? This is what is at the bottom shown here. They are heavily used in security and also monitoring, tracking. So somebody loses their phone, right? The first thing they ask is for information that AMF is having. The information that, because AMF will know everything about us, about our location, where we are connected, how far we are from the tower. So you might have heard of a lot of police investigations, right, where they are able to catch the culprits or alleged culprits, right? Because they know that they keep tracking the mobile tower, and then so that information that provides you our location, our everything is the AMF. So AMF that way is a very key component of any architecture. This was part of the MMA in 4G. So it was part of MMA, which is mobility access and management in 4G. that has been now split, and it has separated from authentication. Earlier, AMF and EUSF, they were all part of same module in 4G. So now that has been split. In 5G, it has become more modular. So you can now use AMF here separately, and then authentication separately. The reason is because your authentication method can keep changing, whereas your access method would be same, because your access method is always through a mobile tower, but your authentication way you identify user could keep changing. Today it is SIM, tomorrow it may be a new type of SIM, or maybe SIMless mobiles. We don't know what else can come, right? So something like that. Uh, so this is where this is the point about AMF. So I know it's like exactly 4:30. So I'll just do a quick check if we want to continue, or you want to continue tomorrow when we discuss with the rest of the components, or I'll just make a quick check. So just put your vote here whether you want to continue or we continue tomorrow. Uh, Tomorrow, okay, I'm getting one response saying tomorrow. So anybody want to continue? Otherwise, yeah, we can do it tomorrow as well. Tomorrow, anyway, we have a full day. So morning, what time are we starting tomorrow? Not tomorrow is what, Wednesday? Yeah, like
The 9:45.
9:45. Yeah, okay, fine. 9:45 to almost 4:30 we have, right? Yeah. So sure. So I think we have enough time tomorrow. We can, because anyway, we have to uh, start looking at some implementation. So after that, so what we'll do is uh, what we will do is we will first finish this uh, description. We'll just go through the rest of the block diagrams, and then I want to show you this something called Docker Hub. So if you go to Docker Hub, so what is important is that there is something called 5G CI. 5G, okay, 5G CI or 5G IC, 5G IC. So if you look at this 5G IC, so you can see this. I mean, this is the beauty of it, right? Like today, you can look at it Dockers. There is already so much Dockers you will be able to see. All this that we are discussing today, SMF is session management function, UPF, user plane function. Again, NRF is network repository function. We'll talk about it tomorrow. UDM, user data management. I don't know what UDR means. Maybe user, it's not there in the specification. But anyway, PCF is a policy control function. AUSF is authentication function. So there are already Dockers available. So all that we have to do is do something like Docker pull. So if you do Docker pull, you will get the Docker on your laptop, and then you can either run it or try bring it up and all that. So those are some of the, as I said, it's not, they are not very crude at the moment. They're not very well. It's not like some of the well mature softwares, because they're all still being developed, and they're still under development. So obviously it will not be usable as it is, but it's interesting to do it. And I think what I suggest you, because if you are continuing to research on 5G or develop your skills on 5G, I would say pick up one function and then develop it on your own, Dockerize it and put it in the in the GitHub on the Docker Hub, so that others can also use it and you can also keep contributing to it. So we will talk about all that a little more tomorrow when we meet again. Yeah, thank you. I think Sunita is saying it was useful, very informative. Thank you, Shinu. So really, thank you for your feedback. I think, yeah, please keep your comments coming. The whole idea of this getting feedback is so that we know what we are doing good. We are not areas that we are not doing good. We want to, of course, improvise, so that when we all deliver the next session, we can make it much better. Okay, so keep yeah, that's good, Shinu. I think I can share a lot of problem statements for you based on your area of interest, whether it is security, routing, policy, authorization, cryptography. There is a lot of 5G cryptography. 5G 5G monitoring itself is a very good area. 5G security. I think I will share some links maybe tomorrow that you can start looking at the attack surface of 5G. So you can just start, because everything is new. See, there is new in the sense it's not that it doesn't exist. So it exists, but it is has to be enhanced. And that is where I think you can start looking at some of the problem statements. And the good thing is 5G is going to stay there, and it's an architecture that is going to sustain for a very long time, and it is reusable. So that way, even tomorrow 6G comes, a lot of fundamental aspects that you're going to develop will still continue to exist. So there's a lot of scope for people who are looking at 5G. Okay, so thank you everyone. I mean, really appreciate your comments and feedback. So I think, yep, we will meet sharp 9:45 tomorrow. So there's a lot of things for us to do tomorrow, especially getting hands-on. And I don't know how many of you have all the software ready, so that itself could take some time. So I think let's start sharply at 9:45 tomorrow. Okay.
Okay, sir. Thank you, Sandeep, sir.
Yeah, sure. Welcome, Yogesh. So we'll meet tomorrow. Thank you, everyone. Bye bye. Have a
Okay, sir.
good evening. Bye.